I'm having a look at the multi-choice questions from the 2024 Maths Methods External Exam from for Queensland. So the first question we have here is finding the integral of x to the power of 4. So when we find the integral, we are going to add 1 to the power and divide by the new power. So looking down my list, I've got 2 that have an x to the power of 5. So D is my answer because it's 1/5 x to the power of 5. Obviously, I have the plus C there. Remember, in multi-choice, we're trying to go as quick as we can. Question 2. Determine the derivative for the function y equals e to the sine x. Now, when we have e to the something into the function, we're going to bring the derivative of that function to the front. So our y dash is going to be cos x e to the sine x there. So that is going to be our A as our answer there. For question 3, we have a worded type question. So we've got a sample size n can be used to obtain a sample p hat. An approximate margin of error for the population proportion can be obtained using the formula. Now this is the one from our formula sheet. This isn't new information. If the level of confidence is increased from 95% to 99%, then the associated, and then you're going through the different options. Now, it's talking about the Z value. So if we go from 95% to 99%, our Z is going to increase. So straight away, we can cross out this one because it says Z will decrease, and this one Z will decrease. So if we're increasing what we're multiplying by, obviously our answer is going to also increase. So that gives us our answer of B. Question 4, we're simplifying y equals 2 ln e to the x. Now we know if we've got ln e to the x, we would bring down that x. Ln of e is 1. We've got 2 lots of that. 2 times x is 2x. So our answer for question 4 was the answer A. Question 5, we are integrating. Now remember, this is tech free, so we can't use our calculators here at all. Now we're integrating between a and b, where a is pi on 3, b is pi on 2, and we've got 2 cos x. So our integral of cos x we know is going to be sine x, and we've got our 2 there. So we're integrating between our pi on 3 and pi on 2, and so we are subbing that in. Now this is where we're going to have to know our exact values. So we've got 2 lots of sine of pi on 2, and we're taking away 2 sine pi on 3 there. Now our pi on 2, we know that sine of pi on 2 is 1, so that's just going to give us 2 there. Here we can go to our exact value triangles. So we've got the 60, 30, because 60 is pi on 3, and we've got our 1√3, 2. So if we've got sine, that's going to be opposite over hypotenuse. So we've got 2 lots of √3 on 2, so that will just be √3 there. So our answer is 2 minus √3, which is C. Question 6, we are differentiating ln x being multiplied by cos x. So that's a product rule 1, uv, where u is equal to ln x. So our u dash is going to be 1 on x. Our v is equal to cos x. So our v dash is going to be negative sine x there. So then we're going to do u dash v plus v dash u. So straight away we can cancel those 2 out. Our u dash v is going to be 1 on x times cos x. So that's the same as cos x over x. So either of those 2 would be correct there. And then we have our minus sine x being multiplied by our ln x. So we're going to get a minus there. So our answer is D. Then we've got question 7. Now there's a little bit of an unusual type one here, a little bit of a trick type question. So 20 families are selected to participate in a lifestyle study related to family size. The number of children in these families is uniformly distributed as shown. So we've got a graph here. We're told if they've got 1, 2, 3, 4, 5 children, how many there are. So there's 4 of each, because there's our frequency there of 4. A random sample of 5 families is chosen from this group without replacement. So a possible mean number of the children in the sample is. Now, if we've got a maximum number of 5, we can't get a mean value of 5 there because we've only got 4 families with 5 and we're not replacing them. So you can only get a maximum of 4 5s, and then the next would have to be a 4, 3, 2, 1. So you wouldn't get a mean of 5. You can't get that. You also can't get a mean of 0 because you don't have any zeros in there, so that's gone as well. And for the same reason as A, we can't get a mean value of 1 because we've only got 4 families of 1. We can't possibly choose 5 families of 1 to give us a mean of 1. So then our answer would have to be B. So that one was a little bit of a trick question. Then on to question 8. Now this one I feel is a standard type of one you're going to see in any of the externals, where you're either comparing, like getting a graph of the function, picking the derivative, vice versa, or in this case, the second derivative. So here we've got our function and we're trying to pick which is the second derivative. Now straight away you could go, this is a cubic, I know my answer is going to be some form of linear, and get rid of those two options. The other way to go about it is, and you still need to determine which one of these ones it is anyway. But first step, whenever I see these type of questions, I'm looking for my stationary point. So I've got one here and one here. So I know that the function is going to have a stationary point at, looks like 0.5 and a 2. And so then I look at the gradient here. So it's positive, negative, positive. So we've got positive, negative, positive as our derivative function. We're then going to do again of that and graph its gradient function, which would then be the second derivative. So we're looking here at our gradient. We've got this turning point here between 0.5 and 2. Both of these cross but at 1, so that's not helpful, but we're looking at our gradient. So we've got negative and then positive. So we've got this one starting in the negative and coming into the positives. This one's starting in the positives, going to the negatives. So that one's out. It has to be C as our answer. Then question 9, another example of why you need to know your exact values and using those triangles, because we've got another question like that. So at a certain location, the temperature can be modelled by the function t is equal to 5 sine pi on 12x plus 23, where x is the number of hours after sunrise. Determine the rate of change of temperature. So rate of change, we need to do derivative. So we're going to do t dash, and here we've got a sine, so it's going to go to cos, what have we got, pi on 12x. Obviously when we do the derivative, the 23 will go, and out the front we will have times the pi on 12 there. So 5 pi on 12 cos pi on 12x is the derivative we're using. Then we're substituting into that x equals 4. So we've got 5 pi on 12 cos of, and here it will be 4 pi on 12. Now 4 pi on 12 is going to simplify to pi on 3. So getting to our 60-30 triangle. So my cos is going to be my adjacent over hypotenuse. So that's going to give me a half, and we're timesing that by 5 pi on 12. So that means we're going to get 5 pi on 24. And up here, that is our answer of B. Question 10. Nice little log question. I love that it has a little bit of a twist there in terms of what you're calculating. So we're told log 10/6 is 0.778. Then we're told we want to find out log 10/600, and obviously don't have our calculators. We're going to have to use that information to see what we can work out. Straight away, I've got a 600, so I know that I'm going to split that and say log 10/6 plus log 10/100 would give me the log 10/600, because 6 times 100 would give me the 600. I already know that log 10/6 is 0.778. I also know that log 10/100 is 2, but if I wasn't sure, I would go log 10 squared. I would bring that 2 down, and then 2 times 1 is 2, so 0.778 plus 2, and that would give me 2.778, which is C there. So a nice little one to finish that multi-choice. In my next set of videos, I'll go through those short response questions individually.